Welcome to EDU World Space.
So here on this problem we are given that sand is released from this hopper with negligible velocity, and this sand falls on this conveyor belt. This one is the conveyor belt, and the mass flow rate coming out from the hopper for the sand is m dash, and we have to develop the expression for the steady state belt speed for h is equals to 0. This height we have to assume it to be 0, and then we have to derive the expression for the velocity of the belt. Now to solve this problem we'll be using the variable mass approach, and let me first show the forces. So the mg force would be acting like this, and there is no other force because we have to neglect the friction. Now this m is the mass of the this sand. So let me first make it clear that what will be the mass of the sand over this length L. So mass for the sand will be equals to the density times the area times the length. This would be the mass. Now the mass flow rate m dash coming out from the hopper will be density times the area times the velocity v. Now we can apply the variable mass approach. And by using this approach we can write that sigma fx is equals to m dot u plus mv dot, and this direction is our x direction. Now there is only one force acting, that is mg. So we will take the component of this force. So it would be, this angle is theta. So if this angle is theta, that means we can take the component, this component would be mg sine theta. So in x direction we have mg sine theta. It will be equals to m dot, we have m dash given in the equation. U here is a relative velocity, which is v here, plus mv dot. Now there is no acceleration for the sand, so this term would be 0. Now m we have rho al times g times sine theta is equals to m dash, we have rho av. So rho av, v times v would become v square. So from here rho and rho will cancel out, area cancel out, and we'll get the expression for velocity to be under root gl sine theta. So this is the required expression that was asked in the question. I hope you have understood the problem. Thank you.